Let vector A is equal to i+4j plus 2k and vector B is equal to 3i minus 2j plus 7k and vector C is equal to 2i minus j plus 4k. Then find a vector D which is perpendicular to both A and B and also given dot product with C and D is 27. So given vectors A is equal to i+4j plus 2k and vector B is equal to 3i minus 2j plus 7k and vector C is equal to 2i minus j plus 4k. And D is a vector which is perpendicular to both the vectors. So we can consider, so the vector D is, which is perpendicular to both the vectors means it is across the A cross B along with A cross B vector. So let us consider some lambda times. So lambda times of A cross B, let us consider D vector. Since a vector A and a vector B, the vector which is perpendicular to both the vectors is normal to the plane containing A and B, and that is represented by A cross B. So our vector D is also along this vector A cross B. So let us consider lambda times of A cross B. So let's find A cross B. The vector A cross B is equal to determinant of i+j+k and scalar components of the first vector A 1, 4 and 2, scalar components of the second vector B, that is 3, minus 2 and 7. Let's find its determinant, which is equal to I times of 28 plus 4 minus j times of 7 minus 6 plus k times of minus 2 minus 12. So that is 32 times of I cap minus j cap and here minus 14 times k cap. So this is a vector A cross B. So that we can write here, therefore the vector D is equal to some lambda times of 32i minus j minus 4k cap, or we can write 32 lambda I minus lambda of j minus 14 lambda of k, and also given that C dot D, dot product with C and D is 27. So given C dot D is equal to 27, so we can consider 2i minus j plus 4k dot product with D vector, that is 32 lambda of I minus lambda of j minus 14 lambda of k, which is equal to 27. Let's find the dot product by multiplying the scalar components respectively. So 2 into 32 lambda, that is 64 lambda, and again, so we can write here minus 1 into minus lambda, and here it comes 4 into minus 14 lambda, which is equal to 27. And let me write even the first one clearly. So it is 2 into 32 lambda. So we have 64 times lambda and again plus lambda, and here it comes minus 14 4 times 40 plus 16, 56. 56 lambda is equal to 27. So we can write here 64 plus 165. 65 minus 56 is 9 lambda. So 9 times lambda is equal to 27, or we can write here lambda is equal to 3. So the value of lambda is 3. Substitute this lambda is equal to 3 in the vector D. Therefore vector D is equal to, so 32 into 3 times of I minus 3 times of j minus 14 into 3 times of k vector. So we can write here 32 3s are, so it is 96 times I vector I cap minus 3j cap minus 14 3s are, so 30 10 3s are 30 plus 12 42, so minus 42 k cap. So therefore the vector D is 96 I minus 3j minus 42 k.